So good afternoon, everyone. So am I audible, ma? So anyone respond in chat box? Hello? Yes, okay, ma. Okay. So right, in previous class we completed the basic cut set matrix and how you can form the cut set matrix. So with that, theory part for network topology is over. So let us see some problems here. How to form the tie set matrix and cut set matrix. So by if you are given a graph. So see this numerical problem. So for this, draw the graph of the network shown in figure. Right here, you are given one network, one electrical network is given here. Now for this electrical network, first you have to draw the graph. Okay, so draw the graph of the network. Then select a tree and write the tie set matrix. So tie set matrix is represented with B, letter B, and cut set matrix with the letter C. Okay, so you need to develop those two. So is this visible, ma? So the letters, what I am writing, is it clearly visible?
Yes, sir.
Okay. So this is the electrical network given. Now for this network, first you have to draw the graph. So how you can draw the graph? So simply you have to replace all the passive elements with the line segments, and voltage sources are short circuited, current sources are open circuited. You know this, right? Here you are having only one voltage source. So this voltage source you have to short circuit. So then all the passive elements are here resistors. All resistors are replaced by line segment. So for this, if you draw the graph, how you can represent? So now the graph will be having all the nodes in the network. So here you have nodes A, B, C, and middle one you can also call it as this is the D. Okay, so total 4 nodes are there. Okay, so A, so then B, C, and D. Okay, so now between A and B you have one element, so that element is replaced with a line segment. Okay, so you have to draw a line segment between A and B. Okay, right. So you call this as a load. So now between A and C also you have one line segment. Between B and C you will get one line. So between A and D, so between B and D, and between D and C, right? So this is your graph. Okay, so now this is not a oriented graph. Why? Because here the direction of currents in each branch is not known, right? Also you represent with the numbers. These branches are represented with the numbers 1, 2, 3, 4, 5, and 6, like that. Okay, now if you give the directions for this, then you will get the orientation graph. Okay, these directions are arbitrary one, you can choose in any direction. Okay, so like this. So now this is the graph of the given network. right? Now from this graph, you have to develop the tie set matrix as well as cut set matrix. Okay, how you can draw the tie set matrix, how you can draw the cut set matrix. Okay, let us see. So first, for both the things, whether it is a tie set matrix or cut set matrix, first you have to select a tree. Okay, so what is a tree? So tree is having all nodes of the original graph. Okay, all nodes of the original graph, but no closed path. So no closed path. Okay, so now from this graph, you have to select all the nodes, but no closed loop. So then you can say that a subgraph is called a tree. Okay, so now I'm forming the tree with elements 2, 5, and 4. Okay, I'm using these 3 branches, right, such that there is no closed loop and all the nodes are included. If you represent them, we'll write it in the next slide here. So between A and D, you have the branch 2, and D and B, you have the branch 5. So between these two, you have branch 4, right? So now all the nodes are included here. Okay, if you see the original graph here, so all the nodes A, B, C, D, all nodes are included, and 2 direction is from A to B, A to D, B to D, and C to D. So all are incoming to D. So directions also you can represent. Okay, so here this direction is in this side, so this direction is in this side, this direction is in this side, and this is the B node and this is the C node. Okay, so middle one is the D node. Okay, now this is a tree. Okay, why? Because it is having all the nodes of the original graph, so but there is no closed path. Okay, how you can form the closed path? If you connect any one link. So what is link? So now here between A and B, you have one link, and B, A and C, you have another link, and between B and C, you have another link. Okay, so see here in the previous graph. So the elements 1, 3, and 6, right? So 1, 3, 6, these are removed while forming a tree. Okay, so with branches 2, 4, and 5, we make a tree, right? How you can make a tree? So by removing these 1, 3, 6 branches, right? Now these 1, 3, 6 branches, with these branches you can form a core tree. Okay, now the branches of this tree are called the twigs here. So these are called the twigs, and branches of core tree are called the links. Okay, now to form a tie set matrix, you need to join one link at a time, so that one closed loop will be formed and one closed loop current will flow here. Okay, so now tie set matrix B is nothing but it is having an order such that these rows will represent the loop currents I1, I2, I3, like that, and columns represents the node branches. Okay, so we already know this, right? So now how you can form the loop? In a tree, if you add one link, so then you can get a closed loop. Now if you add link AB, right? So if you add this link AB, here you are getting one closed loop. Now in this closed loop, you can assume a current I1. Okay, so now if you add the link AC, so AC direction, how it was in the original graph? So from top to bottom. Okay, so direction is from A to C, and here sixth one is C to B. Okay, right. So the direction also you represent before that. Okay, so this is the direction. Okay, now so if you add the link 1, you are framing one closed path, so that in that closed path you can assume the link current I1, right? So now if you add AC, right, AC, then also you can form another loop. Here also you assume another loop current which is I2. Okay, how you can assume this direction? So now you can assume this direction in the direction of your link. Okay, or it can even you can assume it as a arbitrary also. You can even assume in anti-clockwise direction. Okay, so better to assume in the direction of link. Okay, so now if you add the link BC, right? So BC here is, this is the 6th. If you add the link 6, you will get another current, another loop current here. Now in the direction of link, if you represent, that current will be I3. Okay, so now here this is 1, this is 3, this is 6. Okay, 1, 3, 6. So these are the links. Okay, by adding each link to the tree, you can form one closed path. Now the cut set matrix, sorry, the tie set matrix, the tie set matrix. So B is equal to, it is having an order of link currents. So link currents here, it are represented with I1, I3, I6. Or you can or you will assume the loop currents as I1, I2, I3 also you can say. I1, I2, I3 are the 3 loop currents, or those also called as link currents. Okay, now branches are represented with the columns 1, 2, 3, 4, 5, 6. Okay, so now, so what is this element? So in the matrix in the matrix B, the element Bij, so this value will be is equal to +1 if the direction of current through the branch and the assumed loop current are both are in the same direction, right? So if you see here the first branch here, so the direction of branch current is in this direction, and loop current I1 is also in the same direction. So here you will get +1, right? If you see the second branch, okay, second branch current is flowing from top to bottom, and if you assume, if you see the loop current I1, so that loop current I1 also in the same direction, so 2 also you will get +1 only. Now if you see the 3, so this 3 is not there in the loop I1, so here you will get 0. And if you see the 4, so 4 is having opposite to the direction of current I1, so it will be -1. And 5 is not there in the first loop, so this value is 0. 6 also not there in the loop, so it is its value also 0, like that. Okay, so now if you observe the second loop, or now this current I2, in the second loop you are having the elements 2, 3 and 5. Remaining 1, 4, 6 are not having in the second loop, so 1, 4, 6 you will get 0. Okay, 1, 4 and 6 you will get 0. Okay, so then for the second element, second branch, so if you observe the direction of second branch from top to bottom, so but this current, loop current, is in the opposite direction, so for second branch you will get the -1. Okay, so now for 3, so branch 3, if you observe the direction of branch 3 is in the same direction as your assumed loop direction, so it will be +1. And if you observe the fifth one, okay, so if you observe the fifth one, then also your assumed direction will be same as the same fifth current flowing in the fifth branch. Okay, so that also +1. So now you take the third loop I3. Okay, so now here in loop 3 you are having the branches 4, 5 and 6, and 1, 2, 3 are not there in the third loop. So 1, 2, 3, for 1, 2, 3 you will get zeros. Why? Because 1, 2, 3 branches are not there in the loop 3. Now if you observe the fourth branch, this fourth branch current is going from going in this direction, and if you observe the our loop direction, our current direction, it is also in the same direction, so it will be +1. Okay, so now if you observe the branch 5, right, and current, this current will be in opposite direction, so for 5 you will get -1. If you observe the 6, and the 6 is the link current, and this loop current are in the same direction, so here also you will get +1 only. Okay, so now this is the tie set matrix. Okay, so this tie set matrix is having an order of how many loops are there, loops into branches, or link currents into branches. Okay, So this is how you can develop the die-set matrix. So is there any doubt here, ma? So if anyone having the doubt, you can ask me. Okay. So in die-set matrix, so the die-set matrix you have to represent it with the letter B. Okay. So to form a die-set matrix, first you have to select one tree. Okay. So tree is having all the nodes. Tree is having all the nodes, but no closed path. Right. Now the removed branches are called the links. Okay. So links are the removed branches while forming the tree. Right. Now if you add one branch, one removed branch, right, you can get one closed path. Okay. So if you add another removed branch, you will get another loop. If you add another link, you will get another loop. So like that, how many links are there? So those many loops will be there, so that those many loop currents you can assume. Okay. Now based upon these loop currents and the direction of currents flowing in the each branch, you can represent a die-set matrix. Okay. So while forming the die-set matrix, you have to represent the loop currents as rows, and you have to represent the branches as your columns. Now if this I1 is the current flowing in the first loop. Now if the first loop is having the elements 1, 2 and 4, and you have to observe the direction of those currents and your I1, assumed I1. Okay. If they are in the same direction, you will get +1. If they are in opposite direction, you will get -1. So now if the branch is not there in the first loop, you will get simply 0. Okay. Like that you can form the die-set matrix. Simple. Right. So this is finally your die-set matrix. Okay. Right. So next you need to form the cut set matrix. Okay. Now how you can form the cut set matrix for the same graph. Okay. So graph, you draw the graph again. So actually this is your graph. Okay. Nodes are A, B, C and D, and branches are 1, 2, 3, 4, 5, 6, and direction are, so here in this these are in this direction. So these are here in this direction. So this direction is arbitrary. You can select in any direction. Okay. Now you need to develop the cut set matrix for the given graph. Cut set matrix. Right. This cut set matrix is represented with the letter Q. Okay. So now here it will be having an order of. So if you observe this matrix order, so this rows represents the cut set. How many cut sets are there? Independent cut sets. So those cut sets are represented with rows, and columns are your branches. Okay. Now how you can form one cut set? Okay. So now for forming the cut set matrix also, first you have to select a one tree. Okay. So now from this, same as like before, you select one tree, this one. Okay. So this is one tree, so which is having all the nodes of the original graph but no closed path. Okay. Now if you remove the elements in this tree are 2, 4 and 5. Okay. So the direction is top to bottom, here in this direction, here in this direction. Okay. So now what is a cut set? So what is cut set? Now in this tree, in the tree, if you remove one branch, right? So in tree, if you remove one branch, suppose if you remove this second branch, so then what you will get? If you remove the second branch, so then this graph is divided into two parts, right? This is one part and this is another part after removing. Okay. So like this, how many cut sets you can form? how many twigs are there, those many cut sets you can form. Okay. So in a tree, you will be having the branches, right? 2, 4, 5 are in our example. So these are the branches of a tree. Now, if you remove the branch 2 in your tree, so the graph will be divided into 2 parts. So the graph will be cut into 2 parts. So if you remove the branch 4, so the graph will be divided into 2 parts. If you remove the branch 5, the graph will be divided into 2 parts. I will show you one by one, right? So this is actually one tree, right? So this is a tree. So this is a tree. Now from this tree, if you remove branch 2, what you will get? You will get one isolated node A. Okay. So now between B and C, sorry, B and D, you will be having one branch 2. Now between D and C, you will be having another branch 5. Okay, this is in this direction, right? So now you observe this. Okay, so if you observe this, you will be having this after removing this second branch. After removing the second branch, if the graph is divided into 2 parts, right? So this is part 1. So this is part 2. Okay, so this is part 1 and this is part 2. Okay, so the graph will be cut into 2 parts. So if you remove one twig in the tree, okay, so now the set of elements which are here are the links which are going from one part to another part. So now while forming the tree, the removed elements are these one now. So these are called the links, right? So what are the elements? This 1, 3 and 6, right? So 1, 3, 6 are the links here. Okay, now after removing the branch 2, how many links are going from part 1 to part 2 or part 2 to part 1, right? So if you see here, this is going from branch 1 to branch 2, sorry, part 1 to part 2. So this is also going from part 1 to part 2, right? So now with the set with these elements, 1, this is 1, this is 3. So now here you are having 2. So 2, right? So 2 is a twig. So along with this twig, how many links are going from part 1 to part 2? That's total set is called the one cut set. So that means cut set C1 will be having the links which are moving from one part to the another part, which are here 1 and 3. Okay, so 1, 3 along with your twig. So what the removed branch 2. So this is one set. Okay, simply you can represent 1, 2, 3. So 1, 2, 3 is one cut set. Okay, so now in the similar way, if you remove the twig 4, if you remove this 4 here, so then this branch B is isolated. So between A and C, AC and AD, sorry, between these two and these two, you are having the branches, right? So now you have removed this branch. So fourth twig. Now the graph will be divided into part 1 and part 2. Again, two links are going from one part to the another part. Okay. So how what are those links? This link is 1. This link is 6. Now 1, 4, 6 is the cut set 2. So 1, 4, 6. So this is another cut set. Okay. Now if you remove the fifth twig, so then again the graph will be divided into 2 parts. So now how many links are going from one part to the other part means this is 6 and this 3. So along with the twig 5, you can represent another cut set which is C3. That C3 will be so 3, 5, 6. Okay. So these are the cut sets. Okay. So I will represent in the next slide here. So the cut set C1 is, so cut set C1 is formed with what elements? 1, 2, 3. Okay. So 1, 2, 3 is one cut set. Next cut set 2 is formed with this is 1, 4, 6. So with the 1, 4 and 6. And cut set C3, 3, 5, 6. Okay, cut set C3 is with the 3, 5, 6. Okay, right. Now if you represent the tree along with the links, okay, so this is your tree. This is, so direction is in this side, and you are having the links here. So links are represented with the dotted lines, and this is the link currents are in this direction. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay, right, ma. So now cut set C1, cut set C1 will be with the branches 1, 2 and 3. So this is C1, and C2 is with 1, 4, 6. So this one. So this is C2 and this is C3. Okay, so now first you have to represent the cut set on the graph. Okay, now you also assume the direction for this cut set. Okay, so the direction for this cut set you can assume in the direction of your twig here, right? Twigs are nothing but branches of your tree. 2, so 2 is in this direction, so you also assume that the cut set is having the direction in this way. Okay, so for 4 in this direction, for 3 in this direction. Okay, so the direction of your cut set is assumed to be in the direction of your twig. Okay, so now you form the cut set matrix Q. Okay, so with the rows as your cut sets, so rows are your cut sets, columns as your branches. How many branches are there? Total 6 branches. Okay, so now if you observe the cut set C1, okay, now cut set C1 if you observe, so what are the elements that are there in the cut sets? 1, 2, 3. Okay, now for 1, 2, 3 you will be having the either 1 or -1, and the elements which are not having in the cut set C1 are 4, 5, 6, right? So the elements which are not having in the cut set are represented with zeros. Okay, now if the cut set direction and the element direction both are in the same direction, you will get positive. If they are in the opposite direction, you will get negative. Now if you observe this branch 1, so this branch 1 is having in this direction, right? Your cut set C1 direction is downwards in this direction, so it is in both are in opposite direction, so you will get -1 here. Okay, if you observe this branch 2, right? Branch 2 is in the same direction as your cut set, so it will get positive. And branch 3 if you observe, so branch 3 also in the same direction as your cut set, so it is also +1. Okay, next you go with the second cut set, right? Second cut set direction is in this direction, okay, represented by the arrows. Now this cut set C2 also consisting of 1, 4, 6 branches only. Now 2, 5 and 3, 2, 3, 5 are not there in the cut set C2, so those can be represented with the zeros, 2, 3 and 5. Now if you observe the 1, so branch 1 direction and cut set 2 direction both are in the same direction, so it will be +1. And 4 if you observe, 4 is in this direction, so it is same as the direction of your cut set, so it is also +1. Now if you observe the cut set direction C2 and 6 direction, it is opposite direction, so here you will get -1. Okay, so next cut set C3. Cut set C3 direction we are assumed to be in this direction. Okay, now in this cut set you are having only 3, 5, 6. So remaining elements will be represented with zeros. So 1, 0, 2, 0, 3 is there in the cut set, 4 is 0. Okay. Now 3 is, if you observe the direction of 3, so it is from top to bottom, but your cut set is in opposite direction, so it will be -1. Okay. So now if you observe the fifth one and your cut set direction, both are in the same direction, so it will be +1. So if you observe the sixth element, so the direction of sixth element and your cut set direction both are in the same direction again, so it will be +1. Now this matrix is called the cut set matrix. So like this you can form the cut set matrix. Okay. So here, is there any doubt now? So with this second unit is completed. So in the second unit, if you are having any doubts, you can ask me. So still 10 minutes are there. If you are having any doubts, you can ask me. Okay. So now while forming the cut set, again you have to take the one tree. Okay, you take one tree. Okay, so take one tree. So now you also represent the links. So now at cut set C, cut sets are represented with C, C1, C2, C3 like that. Now it is a set of elements, right? How you can form this set? Now if you remove one branch in the tree, so if you remove this branch in the tree, the graph will be divided into two parts. So if you remove this, so then graph will be divided into two parts. This is part 1, so this is part 2. So now from part 1 to part 2, how many links are connected, right? So this link and this link, which are 1 and 3, right? Now along with these 1 and 3 links and this twig 2, the removed branch, that together it forms a one cut set. So 1, 2, 3, it is one cut set. Okay. So second set, how you can form? You have to remove another twig, another branch in the tree. So if you remove the fourth branch, now if you remove this fourth branch here, now then here also you will get one part 1 and part 2 here. So here also from part 1 to part 2 you will get two links. So one link is this one, another link is this one. So this is 1, this is 6, so 1, 4, 6. So this is another cut set, right? So next another set will be a cut set will be found with another branch in the tree, right? With the fifth, if you remove the fifth branch, again this will be divided into two parts. Now from part 1 to part 2, how many links are going? Those links numbers along with the this removed branch. So 3, 5 are the links which are going from part 1 to part 2. Along with 5, you will get one cut set. So 3, 5, 6 is another cut set. Like that, you form a cut set. Okay. Now these cut sets are represented with these lines here. So dotted lines also you can represent. Now for this cut set, you assume the direction. Okay. So now depending upon the direction of cut set, your elements, how they are moving, how the direction of currents are moving the elements. If they are cut set direction and your element direction both are in the same direction, +1 you have to take. If they are in opposite direction, -1 you have to take. Suppose if the cut set is not connected with any branch, that branch value will be 0. So like that you can form the cut set matrix. So this is also called as the fundamental cut set matrix. Okay, I think you are clear. Right. So another problem here. So write the incidence matrix for the given network shown in figure. Okay. So first from the incidence matrix, you have to from the given network, you have to first draw the graph. Okay. So now to draw the graph, you represent the nodes. So 1, 2, 3, 4, 5 nodes are there here. Okay. So current sources are not there, but voltage source is there. Voltage source will be short circuited, and the remaining elements will be drawn like a line segment. So if you draw the graph for this network, first to take the nodes, all the nodes. Okay. So 1, 2, 3, 4 and 5. 5 nodes are there. Now between 1 and 2, you have two elements, 6 and 4. So you can represent them as a line segments like this. You can represent like this. Okay. So this is one branch. This is another branch. You can represent the direction in any as per your wish. Okay. Now between 1 and 4, you have the another element. So 1 and 4 is represented with one straight line. Okay. So direction will be your wish. So then between 2 and 3, we have this, right? So actually here there should be one element. So if the element is not represented here, that means that this node and this node will be the same. So in such a case, only you can take second node only, third node, no need to represent. So why? Because so between 2 and 3, there is no branch is there. So that means no element is there, right? So now 2 is represented here and 3 also represented here. Now in the network, electrical network, here it is represented with one straight line, which is nothing but this 2 and 3 both are the same nodes. So instead of taking the 3, this 3 node, you can take it here itself. Okay, so one simple node only. So in such a case, between this node 2 and 5, you will be having 7 as well as 1. Okay, so here you have the 7 and 1 here like this. So then between 4 and 5, you have another branch. So between 4 and 2, you have one other one. So like this. So now if you represent all the directions also, this is called the oriented graph. Here you can represent the branches with the numbers 1, 2, 3, 4, 5, 6, 7 like that. Okay, so now this is not there in the branch. Okay, so this is only your tree. Now from the tree, you need to form the incidence matrix A, right? So while forming the incidence matrix, you represent the nodes as your rows. So 1, 2. So right, as I said before, this is 2 and 3 are both are same nodes. So I am assuming to be it is only 2, and instead of 4 here, I am assuming it to be 3. Instead of 5 here, I am assuming to be 4. Right, 1, 2, 3, 4 are the nodes. Then branches are 7. So you represent columns as branch 1, 2, 3, 4, 5, 6, 7. Okay, 7 branches and nodes here are 4. Okay, so now here in this incidence matrix, the elements you have to write here as a at each node you have to take. So first node, if you take node 1, you take, right, first node. So at this node, what are the elements connected? 1, 3 and 2. 1, 2, 3 are connected. Remaining all elements are not connected. So not connected elements are represented with zeros. So that means 4 will be 0, 5 will be 0, 6 will be 0, 7 will be 0. Okay, so then you have to observe the connected elements. 1, 2, 3 are connected to the first node, and you observe the direction. If the direction is towards the node, you can take plus. If it is away from the node, you can take it as minus, or in the reverse also you can take. There is no problem. Okay, so now if you see here, first one is towards the node, so I am taking it to be +1. If it is away from the node, I am taking it to be -1. 2 and 3 are away from the node. Okay, so similarly you can represent with all the nodes, right? So if you take second, so for second, 2, 3, 4, 6, 7 are there in the 4, 4, 3, 6, 7. These are connected with the second node. Only 1 and 5 are not connected, right? 1 and 5 not connected, so they are represented with the zeros. And then, so the direction of all the elements, if you observe, 2, 3 is towards the node, and 4, 6, 7 are away from the node. So 2, 3 are represented with positive sign +1, and then 4, 5 this 4, 6, 7 are represented -1. Okay, next if you observe the third node, so for third node 1, 4, 5 are connected, right? So one is away from the node. 4 and 5 are towards the node. They are represented with +1. 4 and 5 are +1, and 1 is -1. Remaining all will be zeros. Okay, so if you observe the finally fourth element, fourth node, For fourth node, 5, 6, 7 are connected. 5 is away from the node. 6 and 7 are towards the node. 6 and 7. So these two will be positive, +1, and 5 is -1. And remaining all elements are not connected, so they are represented with zeros. Okay, now this is called the incidence matrix here. Okay, incidence matrix is nothing but node to branch or node to element matrix. Okay, so if they were asked to find out the reduced incidence matrix, in reduced incidence matrix, you have to take one node as a reference node, right? And you have to remove that particular node row. Okay, if you take this fourth as a reference node, then this total row you have to remove. Okay, the remaining will be the reducing incidence matrix. Okay, so if you observe this incidence matrix, in this incidence matrix, if you take the if you sum the column elements, you will get 0, right? So if you see here, the first column, the total, if you do, the value will be 0. So the value will be 0, 1 minus 1. Similarly for 2 also the same, -1 1. So for similarly for 3 also the same. So if you observe the columns, all columns sum, if you take, you will get 0 only. Okay, so then only you have written correctly the incidence matrix. Okay, so incidence matrix is nothing but simply it is a node to element matrix. So it is having the order of n by e. So now n here represents the number of nodes, e represents the number of elements. Okay, so that's it. Okay, time.
Okay, thank you one and all. Thank you.